our naturalist series training. Today we're going to be talking about our Stream Leaders water quality monitoring program and Macroinvertebrate ID. And so just to let you know, this presentation is being recorded. Actually, Amy, would you mind stopping for just a moment until I bring up the slides? I was just going to do like a little presentation today on monitoring our streams. I'm Sherry Faust, president of Friends of the St. Clair River. And you'll see there that I also have St. Clair County logo on the screen. And that's because this program is a really important partnership of both Friends of the St. Clair River and St. Clair County Health Department. This goes back to about a 10-year relationship and partnership doing this work, and I'll get into more details about that in a little bit. So a little bit about Friends of the St. Clair River. We are the Blue Water Area's largest environmental nonprofit, and we've become the largest nonprofit over the last 13 years. We're led by a very dedicated, passionate, and knowledgeable board of directors, staff, and volunteers, and we really value the rich natural resources of our watershed and committed to improving the quality of life for all the people, plants, and wildlife within our watershed. So our programs look like water and land stewardship. We do water quality monitoring. I'll talk more about that. River cleanups and promoting responsible water-based recreation. And then to help us get all of this important work done, because our watershed spans nearly 1,000 square miles, we can't nearly do that by ourselves. So we recruit and train and manage hundreds of volunteers since we are a small grassroots nonprofit. And training volunteers to do the stream restoration work is really key to this program. So a little history about Stream Leaders. This work cannot be done alone. If you think about the 1,000 miles of waterways just across St. Clair County, it would take a massive amount of resources if we wanted to inventory and survey the health of these waterways. So the MyCore program, which is a statewide program, it's driven by volunteers, was established by our past Michigan Governor Granholm to support a statewide volunteer monitoring program. So this MyCore program establishes very strict protocols about how we collect stream data with volunteers. So as you're comparing data in St. Clair County and you want to compare that to another county in the state, you know that the very same strict protocols are being followed, so the data aligns. We train and recruit teams of volunteers. We assign them to stream sites across the county. We provide all the equipment, and then we send these teams out to collect information on the habitat and the macroinvertebrate population in the streams. So this original grant launched with the health department in 2008. So we've been at this work for a very long time, and the health department and Friends of the St. Clair River rely equally on each other in order to get this work done. So what is the Stream Leaders program? Basically, we're saying that twice a year, once in May, once in September, we go out to stream sites to collect data and collect the macroinvertebrates that live in the water. We're doing this on a 300-foot stretch of stream. You can see there in the bottom corner, some volunteers measuring out not only the stream width, but we also are measuring out the stream length. And then we do our collection within that 300 feet sample. Stream Leaders you can participate in our Stream Leader program from the comfort of your tabletop or armchair. We also have activities to participate on shore with just a clipboard, or if you prefer getting into the water with waders and nets, there's that opportunity also. And so why do we do stream monitoring? We do it because we want to protect our own health. Recreation opportunities tie into overall health of the watershed, but we really need to understand the impacts of pollution on our waterways. Not only are we trying to find the waterways where maybe we need to do some restoration work and bring up the health and water quality, but also we want to find the areas that are in really great healthy condition, and we want to protect those. And so we have to protect the quality of the streams as far upstream as we can go, because those streams lead to our beaches on the St. Clair River that we use for swimming, drinking, and fishing. So what is a macroinvertebrate that I keep talking about here? Benthic refers to the fact that these are bottom dwelling creatures. Macro means that they're large enough to be seen with the naked eye, and invertebrate means that they have no backbone. And so commonly you might hear me refer to them in this presentation as macro, just a shortened word of that, or a bentho, or a bug. And really what we're talking about are these benthic macroinvertebrates, or which are really at the core of how we determine the health of a stream. And so how do invertebrates equal a healthy stream? They have different tolerances to pollution. Some are very sensitive to pollution. Some are very tolerant to pollution. So simply by seeing which macroinvertebrates are present or which are absent, we use it as an indication for the health of the stream. So different macros, different bugs need specific conditions to survive. And depending on the type of bug that we find, and then also the quantity, the amount that we find, we can assess the stream health. So there's a couple different ways that we can assess stream and water quality health. We can do that physically. We can go out and we can see litter and we can pick up litter. We can visually assess a stream very quickly, visual assessment, see what the problems are. That would be like a physical assessment of how a stream is doing. We can also do it chemically is the second way. We can actually collect a water sample and then have that sample tested in a laboratory for various chemical parameters, understanding what sort of metals or bacteria in the water or phosphorus. If you have a well, you're familiar with the chemical analysis of water quality. The problem with that is it's very costly. So we think about the 1,000 miles of waterways across the county. It's cost prohibitive to test all of our streams chemically. So the third way that we can do it is biologically, bioindicators or macroinvertebrates. We use life, bio meaning life. So what sort of animals or plants or fish or insects live in a stream? They can tell us about our water. So why we use macroinvertebrates is because it's a pretty easy sampling technique. They're easy to collect. Pretty much they're generally abundant. With a little practice, they're pretty easy to identify. They're not going very far, so they have pretty limited mobility. When we work within that 300-foot stretch of stream, we know there's going to be macroinvertebrates there. And they're a better indicator overall of a condition of a stream than a water sample. A water sample testing the chemical analysis is kind of just like a one really quick snapshot in time, where a bio indicator like macroinvertebrates gives us a better indication over time. And so our monitoring sites, again, this is drawing on 10 years worth of history of collecting stream monitoring data, span the county. So the white part of this map shows St. Clair County, and then each of the different watersheds that we've worked in St. Clair County are highlighted in different colors there. So we work all the way from the north up in Birchville Township, stretching all the way down to the south in Ira Township, where you see Bobian Creek and Meldrum Creek listed there. Our very urban streams, which would be Stocks Creek, Bunce Creek, and Cuddle Creek, all the way out to more rural streams, which is the Bell River in the western part of the county. So we're trying to get a snapshot of stream health across the county from north to south to east to west, urban to rural. And then what we can do is produce a stream health report card. And this is an example showing the story of how we use macroinvertebrate monitoring to determine if a stream needs restoration or protection. And so this is drawing on some of more of our historical data when we had our original grant about 10 years ago, but gives us a snapshot of this rating system that we use, stretching from poor being the very worst up to excellent being the very best. And we're looking for trends over time. This MyCore program, that statewide program that we participate in, it says you need to have at least 3 years of data before you can start to make a fair assessment or see trends with the stream health. Is the stream trending towards excellent and good? Is the stream trending towards poor or fair? So we can build out trends over time and then really prioritize our management actions based on those trends. And again, management actions might be protecting the stream, like the Bell River tends to score very high. Also, Silver Creek up in Birchville Township trends very high scores. With something that we would expect to see with our more urban streams like Stocks Creek, Bunts Creek, and Cuttle Creek tend to trend towards the poor side of the score. And so maybe we need to direct restoration efforts there. I'm just going to focus on example for one creek that we have been working at pretty consistently for over a decade, and that's Bunts Creek in Marysville, just highlighting a little portion of what that sub-watershed looks like here in Marysville, right adjacent to the St. Clair River here. And here's just a snapshot of what Bunts Creek looks like. So Bunts Creek connects directly to the St. Clair River. Here is the outlet of Bunts Creek. And this is an old photo because this is the former DTE plant that sat right on the shores of the St. Clair River. And Marysville, of course, is no longer there, but Bunts Creek actually traveled underneath the DTE plant and traveled west out through Marysville. It's a very large urbanized watershed, obviously draining all of Marysville and draining all of Kimball and Port Huron townships. And it's actually a county drain. So the county drain commissioner actually manages Bunts Creek. But we've chosen this as one of the locations out of the dozen that you just saw on the map because it's really has easy access and it's wadeable, like we can get in and wade into the stream. So just another little more view here where Bunts Creek came out underneath the former plant, and then Bunts Creek travels west all the way out here through Marysville, and then where we monitor the stream is on the upstream portion, just up here where my cursor is. But there is a barrier here because of the factory that, or the energy plant that existed here. There's a barrier where fish are not able to get up into the stream to use for spawning and habitat. So we know that we need to improve the health of the stream and be able to increase fish passage there. So the data that we're collecting on Bunts Creek will be really important as we look to restore Bunts Creek since this plant came down. Oh, just another overview here of where we're working, and here's the mouth, and then all this blue represents the entire Bunts Creek area. It's very big, and this just happens to be our monitoring site that we've selected and highlighted there. So one thing that we look at, not just like the life, like the bioindicators like macroinvertebrates, but we're also looking at the landscape and how is the land being used right around Bunts Creek? How is the land being used in the entire Bunts Creek watershed? And I mentioned that Bunts Creek is a county drain, so it is managed by the St. Clair County Drain Office. And dredging projects often take place within a county drain to improve flow so that we don't have upstream flooding. And this was the case in 2010, which is the last time the county drain office did a dredging project on Bunts Creek. And you can see how much the land is cleared and stripped away of vegetation from a drain project. This is about when we started doing our macroinvertebrate monitoring. So we have data that shows how life would be impacted when we have a dredging project like this, versus you look over here on the right-hand side in 2015, 5 years after the drain dredging project, how vegetation has been restored and how this might change the macroinvertebrate or life that we're finding here. So not only are we looking literally down in the stream, but we're also looking around the stream to see changes over time. And then how changes on land use and habitat also might change the macroinvertebrate or the living community within the stream. So just a little bit about some of the streams that we do monitor to give you kind of a snapshot of what that work actually looks like. The depth of water can often change too. So I mentioned this MyCore program. We're going out into streams twice a year, once in May and once in September. And often the depth of water changes seasonally. So some of our sites have extremely high and fast water flows in the spring, and then some of them have very slow or shallow waters. So what we're really looking for with a healthy stream is something that has constant water level. Whether that's high or whether that's low, we want to see that constant and consistent. That's best for fish and for wildlife. And then some streams have barriers that are good. So log jams, as you can see here on the left, or what we call woody debris, that's really great habitat. The macroinvertebrates hide there, the fish hide there, and they're all part of the same food chain. So we don't necessarily look at the woody debris and these barriers that are in the stream as obstacles, rather a sign that there's really some good habitat there. Then there's some barriers that are bad, man-made barriers that would be dams. And for instance, this is what Bunce Creek looks like in Marysville. And again, this is a barrier for any sort of fish or wildlife that want to move through the stream. They physically cannot get through past this point. Also, again, I talked about what the land looks like. And so we're doing a physical assessment. So we do the biological assessment, but we do want to do some sort of physical assessment. So we look at the streams that are shaded versus streams that aren't shaded. When we see the shaded streams, we know that the water is going to be cooler. It's going to provide better habitat. When there is no shade, the water heats up, and that's not ideal habitat. So you can see our streams span all different types of habitat and land use, which is really important for us to compare how the data relates to these. And then we can start to make some predictions or assumptions just based on this. And we already saw that, so I'll skip over that. And then the Bell River is one of our favorite rivers to work in because it does have such great habitat and such great diversity of life. And I like to use this photo to demonstrate that. So we have shading from the trees to keep it cool. The riffles are what you see here in front, this change of elevation, adding oxygen to the water, which is really important. We have some logs in here providing habitat, the rocks, and then sort of this bending, turning, meandering channel. All great signs of habitat, and just by a physical assessment, we know that this is going to produce a lot of great diversity of animals, and we know this to be true from the data collection that we've done. So what does the stream monitoring actually entail? So we talked about what it is and why we do it, but like what is literally happening on the shores of the stream? All of these 4 components make up our stream monitoring program. We're doing a habitat assessment. We do a site sketch. The macroinvertebrate collection is the core piece of this, but then also it ends with a laboratory identification. And we have a great partner with St. Clair County Community College to do this laboratory identification piece. So the habitat assessment is more of a conversation where we're talking about the background information of a stream, considering what potential pollutants might be there, particulars of what the monitoring location is, because all of our stream sites are so different. And then what sort of observations are we doing? And so this job is done by the entire team. It starts out the day. We're noting weather conditions, temperature, if it's rained at all, that's going to change the flow in the stream. We're looking for any unusual colors or odors or trash, looking at the substrate composition, riparian vegetation, really just assessing the whole physical attribute of the stream. Kicks off the stream monitoring with this habitat assessment. We do a site sketch, and so we find the people in the team that like to draw or like to sketch, And then we have a sketch over time that's like another physical, tangible piece of what the stream looks like. And so this is done each time at the stream. But the real meat and potatoes and the real work comes in with the sampling and actually collecting the macroinvertebrates. So this is the most important job. We call these the kickers. So they're holding a net. They're actually kicking up and stirring up the substrate. This is where the macroinvertebrates are hiding. Remember, macroinvertebrates are food for fish. So the macroinvertebrates don't want to get eaten. So they're doing their best to hide, and we have to do our best to find them and scoop them up. There is really strict protocol that goes into how we actually do that scooping and kicking, and we train our volunteers to do that. So we do this over a 300-foot stretch in the stream for 30 minutes. And to me, this is the most fun job. The point is not to get wet. The point is to stay dry. So that's why there's waders on. And then also part of the collection job is what we call our shuttlers. So they're shuttling the samples from the stream into a bucket and up onto shore, so we can actually start to sift through all those sediment samples and collect the macroinvertebrates. We have people doing data recording, making sure all of the information that we're collecting over that 30-minute time period is accurate and reflects our samples. They're keeping track of time. And then everybody's job is to pick through the samples on shore. And I tell you what, kids are really good at this because they have such good eyesight and they're so low to the ground. So kids are really great to use for this. The macroinvertebrates' life does come to an end. We do have to preserve them in alcohol, and it's for the purpose of science and studying them. So we collect them from a tray, they go into an ice cube tray and into a jar of alcohol, and that's what we take to the laboratory. But we don't save every specimen. We make observations about the fish, the mussels, and the crayfish that we find. This is an important marker of the wildlife that we see. We mark them and then we release them. And so not all macros are created equal. I told you that they are different tolerances to pollution. And so, like I mentioned, the types of macroinvertebrates that we find, and then also the quantity that we find, is really important to getting us to our stream score. So for instance, when we find these macroinvertebrates, we're going to lean towards a stream score that ranks very high into the excellent rating. And what we're doing is we're actually looking for the macroinvertebrates in their larval form or their nymph form. So they begin their life in the stream. They're an aquatic organism. So we are more familiar with them as an adult, a flying insect or a flying adult later in the summer. But really the stream in the aquatic environment is important to their life cycle. And that's where we're searching for them in. And that's why there's very specific times that we have to go out and look for them in May and in September, because we know this is when we'll find certain macroinvertebrates at this life cycle, this life stage in their nymph or larval form. And so caddisflies are an indication of an excellent stream score, also mayflies. And so mayflies and caddisflies can be a nuisance to people when they emerge from the water and hatch. We've also experienced that at the Blue Water Sturgeon Festival. Typically about the first or second week in June is when caddisflies are hatching by the millions in the lake and in the river. And the message with that is we have really good water quality. So if we can bear a couple days of the nuisance of them being so thick on the water, it's just a really great sign and a really great source of food for a healthy fish population too. And then we move into a stream score that might look a little bit lower, a little bit less. So a good to fair rating. This is still great. It's not bad. We do like to find these macroinvertebrates, but just kind of a step down the scale. So these are macros that we would consider a good to fair stream rating when we find dragonflies and we find damselflies and even sow bugs. So again, we're looking for the damselfly here. and the dragonfly in its nymph form, and while it's still living in the stream. And then, of course, you're familiar with what it looks like as a flying insect as it emerges from its nymph stage in the water. And then we get to those organisms that we find that indicate a poor stream score because they can tolerate a lot of pollution. We can also find them in a really healthy stream. Of course, they'll live in great water quality, but the great organisms won't live in a polluted stream. So when we find the leeches and worms and water striders, this is going to bring our stream score down and give us a lower poor rating. And so many of these macroinvertebrates have such cool stories, and this training isn't specifically going to go into really deep macroinvertebrate ID. That's what we have Saturday set up for. I'll talk a little bit more about that to put this sort of learning today into practice on Saturday on the shores of the Bell River. But just seeing these organisms up close, getting some practice with identifying them. These caddisfly are so unique because they build their home with whatever the substrate is. So for instance, here we found a caddisfly that was using tiny little pebbles in the stream to build its home or its case, and this is how it stays protected. This is also an entire collection of caddisflies, and by first glance, if you're in a stream, you would never give a second glance that think this is actually a living organism that indicates good water quality. But with a little practice and a trained eye, we realized that these were all caddisfly homes, and caddisfly were living inside of all of these. So they were using like a twig or a wood substrate. So that is just so cool that these bugs are fighters and survivors against all odds. And mayflies are really exciting to find too. And they have these gills on the side of their body that are like feathers that they use for breathing. And once they emerge as an adult, they have a super short lifespan. So a lot of the macroinvertebrates have a really cool story and evolution about how they move from aquatic to terrestrial in their very short lifespan. A cranefly can often be confused as a mosquito, but they're not. They're a fly. They are in the same family as mosquitoes, but otherwise they're very different. And where you can find them on the bottom of a stream is under dead leaves or debris. So it's really important that we're searching all parts of a stream when we're looking for all different types of macroinvertebrates, because they inhabit different little niches in a stream. The cranefly is going to inhabit a niche of between dead leaves and debris. Adult cranefly will not even eat. Its only one purpose is to mate and lay eggs, and then it dies. So our macroinvertebrate collection protocol, we have to, when we're in the stream, we look at as many of these different microhabitats as possible, because I said the different habitats yield different macroinvertebrates. So I'm gonna go through a couple photos here just to kind of give you a little quiz. I'm gonna pull up some photos of some of these different habitats and quiz you to say which habitat is portrayed in this photo. Because that's how we conduct our stream monitoring program, understanding what each of these habitats look like, and then actually putting into practice when we're out in the stream, making sure that we're seeing all of these and collecting samples from all of these. So for instance, when we're working in a stream, we want to understand the composition of the stream, and that's understanding the run, a riffle, and a pool are all different areas within a stream. So a run that I show them here, and I'm standing at the upstream area, so I'm showing the flow of water is moving downstream, moving away from me. And the run is the long, straight, consistent, level flowing part. That always moves into a riffle. And so here we have a change of elevation. There's a drop in elevation. Riffles are really important for adding oxygen to a stream. So when we see a riffle, if you're ever out in the outdoors or in any stream or river, you see a riffle, you know that's a really great habitat there. So we always move from a run, always moves into a riffle, and always following a riffle is a pool. And this is the deep settling area where the water becomes very deep and calm. It kind of ponds and pools there. If you were walking along, you would find that you would like go in very deep there. And so this is kind of the ecology of a stream. And then it begins all over again. This might stretch, this sequence might happen over a mile long. It might happen over 100 feet. Okay, so can you guess the stream habitat? So I just put those other stream habitats on the screen so quickly just a moment ago. But here you can see someone collecting a sample here. And so maybe if you are muted, you can unmute, or Amy, you can monitor the chat. So you can either say this out loud or put it into the chat. What would you guess this stream habitat to be here? And you don't have to use any technical jargon or anything like that. You can just make a simple observation about where this collection is happening. Well, I will tell you what we call this is, it could be a couple things. It could be the stream margin. So we're working within the margin or the outside border of a stream. So we could call this the stream margin. We could also call this an undercut bank. So the vegetation is hanging over the water and the water is underneath the vegetation. So we call that an undercut bank. So this is actually good habitat and an area that we would want to sample. Okay, what about here? Can you guess this stream habitat?
A pool.
Oh,
Yep, go ahead. Yeah, pool. I would agree with that. It almost looks like it has a lot of cobble, and the cobble are what we call rocks. So you can see a lot of cobble here or rocks, and definitely this person is standing in a deeper area than this person. So we might say that this is a pool, but also might have a rocky substrate, which would be important. Macroinvertebrates like to hide under the rocks. Which again, it kind of, I guess, leads into this one, what we would call this cobble or rock. And these volunteers are simply just picking up the rocks by hand and flipping them over and looking underneath them. So also an important collection technique is to look to see where those macroinvertebrates are hiding. Remember, they're being elusive and we have to do our investigating. And then what would you call this stream habitat?
Woody debris.
Mm-hmm. Yep, you can see they're getting their net right in there and jabbing around and looking under that important habitat of that wood. And then the final step, the fourth step, is that we take all of our samples into the laboratory, here in this case, the SC4. And the final step is we do an initial identification in the field, but we really need to confirm our identification under a microscope. Sometimes what we think might be a mayfly in the field actually turns out to be a damselfly when we look at it under a microscope, or vice versa. So this confirms our final stream score, and we can decide if the stream is excellent, good, fair, or poor.
Hello.
And I just like to end with this picture. This was Emma. She's 8 years old. She came to one of our stream monitoring events and she made this tank top, and it was just so clever. And she gets it. She gets that before you squash your next bug, remember, no bugs, no food. So we really can't remember, or we really can't forget why we are doing this. And so thanks to Emma for getting that message.
Emma, who's probably 18 now.
Yes. I know, but she'll always be our poster child for really the true message. And just the final slide here, just to put a plug for some of our programs that are coming up here. You can go to our website, scriver.org/events, and you'll find a listing of all of our events here. What I want to bring your attention to is Wetland Wanderings right here in the middle. That is our Wednesday programming in the summer, June, July, and August at Wetlands County Park, which is on the Blue Water Riverwalk in downtown Port Huron. And the Wetland Wanderings, we're putting this program into practice, and we need volunteers to come help us test the water quality using these macroinvertebrates to understand the health of the wetlands. And again, we're building a database of data of these, and I believe we're entering into our 3rd year, so we can start to understand the health of the wetlands with this macroinvertebrate monitoring. So Wetland Wanderings, I highly recommend. It's a fun hour of your evening to spend on a Wednesday. And then we have our Blue Water Sturgeon Festival coming up on Friday, June 4th, and you can learn more at sturgeonfestival.com. I want to thank you for joining us today. Thank you for learning about our stream monitoring. You can join us this Saturday, which is May 15th at Columbus County Park at noon. We'll be on the shores of the Bell River, actually putting all of this knowledge into practice, into training to show you how to do this, to get ready for our fall stream monitoring program, because we received a grant through the St. Clair County Health Department to revitalize our 10-year-old grant and to get back out in the stream. So we're really excited to do that and build on all of the knowledge and data that we've collected over the years and continue to expand stream monitoring. So thank you very much. And we'll wrap up the program and we'll get into question and answer. So thank you.